Hey guys, Mr. Milton here. Today we're looking at mid-segment notes. At the end of this video, you should be able to explain what a mid-segment is and give it special properties. And you should be able to use mid-segment to find missing measures. Okay, here's what a mid-segment is. A mid-segment is a segment connecting the midpoints of two sides. Okay, so you'll notice here that XY is a mid-segment. And here's how we know. Px is congruent to xm, so it must mean that x is the midpoint. Py is congruent to yn, meaning that y is the midpoint. So xy is the segment that connects the midpoints. Okay? So you can write that down. Listen to the explanation. All right, it says, is DE a mid-segment? Why or why not? And the answer is, there's not enough information. We don't know. We can't say it is, right? We would know if it was a midpoint if they told us that AD was congruent to DC or that AE was congruent to EB, but they don't tell us any of that, okay? They just have D somewhere near the middle and E somewhere near the middle. So there's no indication right? And that's what we really would want to have in order to say that this is a mid-segment. Okay, not want to have, we need to have it. Okay, triangle mid-segment theorem. If a triangle has a mid-segment, then it is parallel to the third side, and it is half the length of the third side. Okay, so a mid-segment isn't just this thing. It actually has properties that are consistent. It's going to be parallel to the third side and half the length of the third side. Another way of saying number two is that the third side is double the length of the mid-segment, or twice the length of the mid-segment. Okay, so here's the recommended thought process for a problem like this. We're given the triangle AB or ADE with mid-segment BC, and we have X in our third side. So what we're going to say is, all right, we're trying to find X. Here's what we should think. Okay, if BC is 6, what's the length of DE? Well, DE must be twice the length of BC. So we know that this is 12. 2 times 6, that's how we got to that point, right? Twice, DE has to be twice the mid-segment. So since we know that, now we can solve this and say, okay, we know that X minus 1 is 12. Add 1 to both sides. X then must be 13. All right, here it says find the value of X given that AY is congruent to AX. AY is congruent to AX. And BY is congruent to BC. Okay, great. So they gave us information to say, hey, AB is a mid-segment. So everything that we know about mid-segments should be true. All right, so if that's the case, then we know that 3x minus 1 is half of xz. So since xz is 34, half of that is 17. And now we start to solve for x. 3x, add 1 to both sides is 18. Divide by 3, x is 6. So the value of x in this case is 6. All right, it says find the perimeter of ABC given that D, E, and F are midpoints. This is a midpoint. This is a midpoint. This is a midpoint. All right, so all these are midpoints, meaning all of these are mid-segments. Okay, so this is how we can think about this. 8 is a mid-segment. It must be, DE must be half of AB. So if DE is 8, AB then must be 16. Okay, 7 is a mid-segment. It is going to be parallel to its third side, the side it doesn't intersect. So that's this side here. That means this side must be then 14. Okay. 3 is a mid-segment. Okay, it's connecting two midpoints. So this side that is parallel to must be twice the length. Okay, so now we have all three of those sides. We base those lengths off of their corresponding midsegments, 22, 36. So the perimeter of triangle ABC is 36. Says, how does the perimeter of triangle ABC compare to the perimeter of triangle DEF? Well, DEF is 8 plus 3, 11, plus 7, 18. So you have 18 over 36. Well, look at that. It's a 1-to-2 ratio. Okay. ABC is double. Oops, that's supposed to be DEF. ABC is double DEF. Okay, which makes sense. Our midsegments are half the length. And so, yeah, all those sides should be double. All right, so we're doing the same thing now here with a little bit more variable to it. So it says find, for the next examples, find the values of for the next examples, find the values of the variables. So here, they're giving us this point. Here's a midpoint. Okay, it's a midpoint, they tell us, because they're marking these sides congruent and these sides congruent. So this line is a midsegment. So X then should be half of the side is parallel to. What side is parallel to? The length of the side is parallel to is 28. So X equals 28 over 2, or 14. Finding Y, okay, again, they're marking for us that 15 is a midsegment. Okay, so 15 is a midsegment. It should be half the side it's parallel to. So if this is 15, that must mean that this side is 30. So Y plus 6 then is 30. Subtract 6 from both sides. Y is 24. Number 2, it says the given line is a midsegment. So now we don't have to worry about is it a midpoint or not. They told us, they basically told us they have to be. It's the definition of a midsegment. So now that we know that, 2 things that we can help ourselves with. Well, 2 different types of problems, so let's solve these. X plus 4 and 4x minus 2 are the sides that we have to think about together. X plus 4 is half of 4x minus 2. Okay, so we can think of this 2 different ways. The way that I would like to think of it is, since this is half of 4x minus 2, if I multiplied it by 2, then now they should be the same, right? Okay, the other way that we could set this up is x plus 4 equals 1/2 of 4x minus 2, and that will work just the same in this case. But what I would like to steer away from is doing this all the time, because a lot of times this might give us a fraction or decimal, and this multiplying by 2 helps us to not have it. So these 2 are equivalent. They're about the same thing, but I like this one better. So here we go. We got 2x plus 8 equals 4x minus 2. Start solving. Subtract 2x from both sides. Add 2 to both sides. And we find out x is 5. Okay, now we have to find y. You might say, oh, we haven't talked about the sides a whole lot. We haven't, but they did tell us that this is a midsegment. So our definition of midsegment is that it must connect 2 midpoints. And so that means we know something about this side that they didn't necessarily dive into a whole lot. So that 4y must be the same as 6y minus 1. So 4y equals 6y minus 6. 2y equals 6. Y equals 3. Okay, should make sense. The last one here, it says, what is the measure of VUT? Asking about this angle here. Given that V, E, and U are midpoints. Okay. So they told us that V and U are midpoints. And you might be like, well, we're not really looking for side length, so how does that work? Well, because they're midpoints, remember that this other property of our midsegment was that it was half the length of our third side, which we've used a lot, and it was parallel to our third side. So here we have parallel lines. Remember that whenever you think of parallel lines, hopefully in your mind you're like, oh, alternate interior angles, corresponding angles, same side interior angles, right? And corresponding angles present itself in this problem here. These two are corresponding angles. Okay, so because they are, angle RSV and angle UVT should be 81 degrees. Okay, that helps us because not because that's the angle that they're asking us about, but because in this triangle we have two angles, 81 and 32, and we know that all three of these angles should add to 180. So 81 plus 32, 180 minus 113 gives us 67. So VUT is 67 degrees. Okay, why? Well, we used corresponding angles postulate to show that angle UVT equals 81 degrees, right? Then we used triangle angle sum to find that VUT equals 67. Okay, and all that comes from VU being parallel to SR because midsegments are parallel to the third side. All right, that is your midsegment notes as we start our last chapter. See you.